Welcome to Eduonix Learning Solutions for our course for GraphQL for beginners. In this session, you will learn all you need to know about the GraphQL type system and how it describes what data can be queried. Since GraphQL can be used with any backend framework or programming language, we will stay away from implementation specific details and talk only about the concepts. So the first concept that we have to come across is a type system. So if you have been seen a GraphQL query before, you know that GraphQL query language is basically about selecting fields on objects. So for example, the following query if we see, so we start with the object, say what? Say film, and then we provide the film ID, say for example 10. And now we know there are specific fields to it. So let us type field. So once you press Control space, we'll get the options according to the fields that are available. So say for example, title, episode ID, and then we'll run this pressing Control Enter. So we have got an error over here which says no entry in local cache. So we can change the ID, say for example keep it to the 1, and now we see it says the title of the film is A New Hope and the episode ID is 4. So if we observe over here, we started with a special root object that was film, and then we select the field film ID, and the field that we selected is title, and for the object returned by the title is A New Hope, and if we want we can add furthermore fields into it which again have subfields. Say for example, if we select planet connection, so it has got its own fields, and once you run it they will autofill. So if we see over here, so the shape of the GraphQL query closely matches the result. You can predict what the query will return without knowing that much about the server, but it's useful to have a description of data we can ask for, what fields can we select, what kind of object might return, and what fields are available on those sub-objects. For example, as we saw in a planet connection, there are sub-objects to its edges, node and ID. So that's where the schema comes into the picture. Every GraphQL service defines a set of type which completely describes the set of possible data. You can query on that service, then when query comes in, they are validated and executed against that schema. So talking about type language, so GraphQL services can be written in any language. Since we can't rely on a specific programming language syntax like JavaScript to talk about GraphQL schemas, we will define our own simple language. So we will use GraphQL schema language. It's similar to a query language and allows us to talk about GraphQL schema in a language agnostic way. Now let's talk about object types and fields. The most basic component of a GraphQL schema are object types, which just represent a kind of object you can fetch from your services and what field it has. In a GraphQL schema language, we might represent it like this. So let's type it. So say type, and then we kept type as a character, which see what it is. But for the time being, let's type it first and then write about substrings or subfields. If we say, so this has to be string type, and another subfield appears. So this is just a name of the field, and it has a type, say episode. Now this is pretty easy to learn and to read and to understand. The language is pretty readable but let's go over it so that we can have a shared vocabulary to this. So character is the GraphQL object type, meaning it's a type with some fields. Most of the types in your schema will be of object types. Name and appears are fields on the character type. That means the name and appear are the only fields that can appear in any part of the GraphQL query that operates on a character type. String is one of the inbuilt scalar types. These are types that resolve to a single scalar object and can't have subselection in the query. So we'll see scalar types more detail in later. And string exclamation, if I say, means that the field is non-nullable, meaning that the GraphQL service promises to always give you the value when you query this field. In this type of language, we will represent those with the exclamation mark. And episode represents an array of episode objects. Since it is also non-nullable, you can always expect an array when you query appear in field. Coming on to the arguments, now every field on a GraphQL object type can have 0 or more arguments. For example, if we look at this code in here, there is a type starship, then ID has got the ID type, name has got string, and if we look at the length in here, length field in this code, so all the arguments are named. Unlike languages like JavaScript and Python, where function takes a list of ordered arguments, all arguments in GraphQL are passed by name specifically. So in this case, the length field has one defined argument and it is unit. So arguments can be either required or optional. When an argument is optional, we can define a default value. If the unit argument is not passed, it will be set to meter by default. So now talking about the query and mutation types. So most types in a schema will just be normal object types, but there are two types that are special within the schema. So every GraphQL service has a query type and may or may not have a mutation type. These types are the same as regular object type, but they are special because they define the entry point of every GraphQL query. So if you see a query that looks like this, let's type the query. So say for example you type query and in the curly brackets you say for example starship, mention its ID, and now say for example we need name, then we need model, and then we need pilot connection. Now this has got its own subfields, say for example page information, and now page information over here has got its own different set of fields. So for example, if we run it, it shows there is some syntax error into it. Let's try and understand. So it says we actually forgot to mention the ID for the ship we are sending a query for. So now let's hit the play button and see. So query has come. So it may look like some random data, but the structure reflects what the query is being sent for. Once I send this query, this means a GraphQL service should have a query with the name starship and with the subfields as pilot, name and model. Now coming on to the scalar types, Let's keep the example same and talk about the scalar types. A GraphQL object type has a name and fields, but at some points those fields have to resolve to some concrete data. That's where the scalar types come in. They represent the leaves of the query. So for example, over here in this page info has page next or start cursor, or if you include any other name here, so say for example end cursor if I include, so these are not basically subfields, they are the leaves of the query. So GraphQL comes with a set of default scalar types which are out of the box. So it has integer type which is int, so assigned integer, that is 32-bit integer. Then the type is float, assigned double precision float point value. It also has string, so a UTF 8-character sequence. Then it also got boolean, so which may be having the two values either true or false. It also has a ID scalar type, so represents a unique identifier often used to refetch an object or as a key for catch. The type ID is serialized in the same way as a string. However, defining it as an ID signifies that it is not intended to be human readable. In most GraphQL services implementation, there is also a way to specify custom scalar types. For example, we could define a date type. So say you can say scalar and then you can define it as a date. So then it's up to our implementation to define how that type should be serialized, deserialized and validated. For example, you could specify the date type should always be serialized into an integer timestamp and your client should know to expect that format for any date fields. Coming on to the next type, that is enumeration type, also sometimes called as enums. So enumeration types are special kind of scalar that is restricted to a particular set of allowed values. So this allows you to validate that any argument of this type are one of the allowed values. So and second, communicate through the type system that a field will always be one of the finite set of values. So let's look at the example. So you can say enum episode and then you can specify New Hope or JD. So now this means whatever we use or wherever we use the type episode in our schema, we expect it to be explicitly exactly one of the New Hope or JD. Note that GraphQL service implementations in various languages will have their own language specific way to deal with the enums. In languages that support enums as a first class citizen, the implementation might take advantage of that. And in a language like JavaScript with no enum support, these values might be internally mapped to set of integers. However, these details don't leak out to the client, which can operate entirely in terms of the string names of the enum values. Now let's talk about lists and non-null. So object type, scalars, enums are the only kind of types that you can define in GraphQL. But when you use the types in other parts of the schema or in your query variable declarations, you can apply additional modifier that affect the validation of those values. Let's look at the example here. You say type character and then if we specify, for example, name and we take it, keep it as string, rest needs to be capital, and put exclamation mark so that we expect server not to return any null value. And along with that, if suppose for example we have another field over here that says appear, for example, and we keep it as a type episode, and again we put exclamation mark so that it shall not return any value, null value. For example, here we are using string type and marked as non-null by adding the exclamation mark after the type name. This means that our server always expects to return a non-null value for this field, and if it ends up getting a null value, that will actually trigger a GraphQL execution error, letting the client know that something has gone wrong. The non-null type modifier can also be used when defining arguments for a field, which will cause the GraphQL server to return a validation error if a null value is passed as the argument, whether in GraphQL string or in the variables. So let us see one more example. So for example, we say, let's say query. You can give any name to the query. For example, I name it as a films, and in the bracket we'll define the variable, for example ID, and give it a type ID, for example here, and we'll again give the exclamation, and we will give the exclamation, and after that we have to put a query, and we take film ID, which will be referring to the ID provided by the variable ID. And now what would we like to know? We like to know the title or episode ID, or again we say the name of the director if we want to, and the name of the producers if we want to. So once we write the query in this manner, under the query variable, for example, here already 2 is been passed. Now if I hit enter, I'll be able to see, because I have provided a non-null value as 2, a value is been returned. But if I as soon as pass a value null to it and try to run it, I'll be able to see an error message has been given. That's because it's unrecognizable. So if you pass, say any other value, say 1 for the time being, I still get those values from the server. Lists work in a similar manner. We can use a type modifier to mark a type as a list, which indicates that this field will return an array of that type in the schema language. This is denoted by wrapping the type in a square brackets. It works the same for arguments, where the validation step will expect an array for that value. The non-null and list modifiers can be combined. For example, you can have a list of non-null strings. So for example, let's see. So for example, if I be able to declare any field as a string, I put the exclamation for non-null values to be returned. Now this is just an example. So for example, this says the list itself can be null, but its members cannot be null. So if you look at the line number 3, so my field null is valid, my field with the brackets, square brackets, valid. If you look at the line number 4, my field with square brackets as an empty is valid. My field with some values on a 5th line is valid. But if you check at the line number 6, so A null B, which gives us the error. Now let's define non-null list of string. So if I say my field and I take string, putting exclamation outside, and now I put the exclamation outside, and now see what are the valid fields or valid arguments. So for example, here my field null is an error, but my field with empty braces or brackets is valid. My field A and B, that means with arguments, it's valid. And along with that, if an argument is null, for example, A null B is also valid in here. So talking about interfaces, like many type systems, GraphQL also support interfaces. So interface is an abstract type that includes a certain set of fields that a type must include to implement the interface. For example, you could have an interface character that represent any character in the Star Wars trilogy. So for example, if we look at a code here, so it says interface character, then it has got ID, which has got type ID, name, which has got type string, so friends, which has a type character and appears in, so we have to provide the episode number here. So this means that any type that implements character needs to have these exact fields with these arguments and return types. So for example, if you look at a type statement in here, so type human, and now we are implementing a character, so ID, name, friends and appear in are same, but we have the additional fields also depending on the particular type and that are specific to that particular character. So for example, starship and total credit are specific to human, and if you look at the type droid, it has got extra statement or extra option, that is primary function strings. So interfaces are usually useful when you want to return an object or set of objects, but those might be of several different types. Now let's take a query which will generate an error. So let's see. So for example, if I write this query, so query hero for episode, and now the type is being given as episode hero episode $AP, since we are going to pass a variable to it, and then the primary function. So if you observe over here, we have got the error, so message cannot query field primary function. So the hero field returns the type character, which means it might be either human or a droid depending on the episode argument. In the query above, you can only ask for fields that exist on the character interface which doesn't include primary function, but it is possible to do it using the inline fragment. So to ask for a field on a specific object type, you need to use the inline fragment. So let us see how we can use the inline fragment now. So we have made a use of inline fragment here. So if you can see on droid in the same query, on droid, and then primary function is being taken under the droid, and then it has been queried. So we are able to see the response has been written as name R2D2 and primary function astromac. So now let's talk about input types. So we have only talked about passing scalar values like enums or strings as arguments into field, but you can also easily pass complex objects. This is particularly valuable in the case of mutations, where you might want to pass in a whole object to be created. In the GraphQL schema language, input type looks exactly in the same as regular object types, but the keyword input instead of type needs to be used. Here is the example how you can use input object type in a mutation. So now say input review input, and then we have taken stars as a int and commentary as a string, and now we have created a mutation. So mutation create review for episode, so episode and then review input, and create review. So we are passing these values. So now says EP and then $review, and while passing the query, EP as JEDI JD and review as stars 5 and commentary. So value will be returned to us. So what changes had happened? So we are passing the object instead of type. So we are now able to pass complex objects. So the field on an input object type can themselves refers to input object types, but you can't mix input and output types in your schema. Input object types also can't have arguments on their fields. Let's talk about the validation. So by using a validation, the type system, it can be predetermined whether the GraphQL query is valid or not. This allows servers and clients to effectively inform developers when an invalid query has been detected without having to rely on a runtime check. So to start, let's take a complex valid query. This is nested query similar to the example from the previous type, but with the duplicated fields factored out into a fragment. Let's say Starship, and provided with the Starship ID, for example, let's take it as 5, and I have to use a fragment. So for time being, we'll give the fragment and declare it later on. We'll just provide the name, and we have to say, so for example, we want a pilot collection here. Or before we provide any fragment name, let's take some fields. So for the time being, I'm taking a field as a pilot connection here, and it has got its own subfields. So there are edges, and edges has got its own field, say for example node, and node has got name, for example. And now I will go and declare a fragment, say over here. So name of the fragment is, so its name and appearances, appearances, and then what I am going to declare on, it's going to be on a Starship. So you can press Control space bar and now specify it was on name and it has a pilot connection. We has got different things, say for example page info, we'll keep, has got its own field, say has next page, and if you want you can keep another field too, say for example length over here. And now mention this fragment at the top and say name and appearances, appearances, appearances. Run the code, you will be able to see it is the valid code. It is extracting the data, required data. And now let us see what are some invalid codes or what will cause invalidity of the code. So one by one let's see. So it's about using fragments at different pieces or at different locations or at different ways which may lead to the invalidity of the code. So a fragment cannot refer to itself or create a cycle, as this could result in an unbounded result. Here is the query. So for example, suppose if I take name and appearances and try to paste it and create a cycle in itself, so we are able to see that it will show the query is not acceptable. So we have got the error. So this specifies the invalidity when you try to use a fragment inside its own self or as a cyclic way. Whenever we are querying a field, we have to query a field that exists on the given type or exists in the given query. So as for example, let's do it. So if I say film and I have to specify the film ID, let's for example take 4, and now there are subfields to it. Now for example, there is no name field to it, but if I try to type name, it shows the error. So if we read the error, it says cannot query field name on type film. So if you try and specify a wrong code or wrong field which is not present in the given field, that shows the error. Now for example, title belongs to film. If I try to run it, it will run, and name was not the field that exists. So it shows the error that cannot query a name on a type film. So this is the invalid query and shows the error. Another way is whenever we query for a field and it returns something other than scalar or enum, we need to specify what data we want back from the field. Now for example, if I say film and even if I specify film ID, but if I don't specify what am I expecting, it won't return anything, so it shows error. So what I need from film, even if I specify the film ID over here, say for example, still it won't return the required fields. For example, it is not returning the title, the episode ID, only it is returning the ID, which is not a relevant query. So we have to specify what we need. Say for example, we need title, we need episode ID, so we need to specify them to get it. So it won't automatically throw the fields whenever the query is being raised. Now for example, let's again take the same example of films. For example, if we specify the film ID and whatever ID you provide, say for example 1, and now let's take a title, and if you try to take anything out of title, now for example you say ID, but this is not something that exists inside title, then it will give you the error. So if a field is scalar, it doesn't make sense to query for additional field on it, and doing so will make your query invalid. So this is also the way that makes our query invalid. Now let's look at another example. So for example, if I declare a fragment here for the time being and say fragment new on starship name and model, and if I try to include this new inside the title, it will give the error because it says the field title must not have a selection type string, has no subfields. So that means it's not accepting under the title, so it must match. Now for example, if I take new here as well, which won't be acceptable, so this again generates invalid query. So this has just scratched the surface of the validation system. Now there are a number of validation rules in place to ensure that GraphQL query is semantically meaningful. Next, look at the execution. So talking about the next aspect, that is execution. Now after being validated, a GraphQL query is executed by a GraphQL server which returns a result that mirrors the shape of the requested query, typically in JSON. So GraphQL cannot execute a query without a type system. Let's use an example type system to illustrate executing a query. This is a part of the same type system used throughout the example in these articles. In order to describe what happens when a query is executed, let's use an example to walk through. So now let's try to raise a query and say human, for example, and in the bracket it requires an ID, and ID over here is a character data. So whatever it may be, say for example 1002, if you take, and then it has got subfields. So now you will say, so control enter will tell you what all fields are available. So let's take name and like appears in, and take, let's keep adding more fields. Say for example friends. So now friends has its own field. So it has ID, it has got name and so on. So now if you run this query, so we say the data is being pulled. So you can think of each field in a GraphQL query as a function or a method of the previous type which returns the next type. In fact, this is exactly how GraphQL works. Each field on each type is backed by a function called a resolver, so which is provided by the GraphQL server developer. When a field is executed, the corresponding resolver is called to produce the next value. If a field produces a scalar value like a string or a number, then the execution completes. However, if field produces an object value, then the query will contain another selection of fields which apply to that object. This continues until scalar values are reached. GraphQL queries always end at the scalar values. Let's talk about root, fields and resolvers. So at the top level of every GraphQL server is a type that represents all of the possible entry points into the GraphQL API. It's often called root type or the query type. So in the example, our query type provides a field called human which accepts the argument ID. The resolver function for this field likely to access the database and then constructs and returns the human object. So say, how will we raise a query? So for example, we will write query, try to clean this up, and write query, and in the bracket we say human, and what you want to be written. So say object, comma, arguments and context is what is needed, and then what you want in return. So we want context dot db dot, now we say load human by ID. So to specify what, then it says args, that is arguments dot ID, and then close it. Now we already see what is dot then says. So it's a response. So it says it has to take user data and which has to be new human, and it is a user data that we are expecting, and now close it. So now this example is written in JavaScript. However, GraphQL servers can be built in many different languages. A resolver function receives 3 arguments. So one is obj, the previous object, which for field on the root query type is often not used. Args, the argument provided to the field in the GraphQL query. And it is also context, so a value which provided to every resolver and holds important contextual information like the currently logged in user or access to a database. Now, next we have is asynchronous resolver. Now, let's type human, and in the bracket let's mention obj, comma, argument, comma, context, and we have to return like we did it in the earlier query too, and that we have to return is context. So we have to return context dot db dot load human by id, and in the bracket we have to specify id and then the same command. Then what you want to pull, it's user data, and it says okay, so it has to be new, right? And then we need, so query is still the same, but we have certain things to be observed here. This human, and in the bracket we have to write user data. And now the context is used to provide access to a database which is used to load the data for a user by ID provided as an argument in the GraphQL query. Since loading from a database is an asynchronous operation, this returns a promise. In JavaScript, promises are used to work with asynchronous values, but the same concept exists in many languages, often called futures, tasks, or deferred. When the database returns, we can construct and return a new human object. Notice that while the resolver function needs to be aware of promises, the GraphQL query does not. It simply expects the human field to return something which it can then ask the name of the during execution. GraphQL will wait for the promises or futures and tasks to complete before continuing, and will do so with the optimal concurrency. Next is trivial resolvers. So say how this will look like is, so it says human, and then in the bracket we specify name, and you have to tell it that there has to be object. Of course, arguments are again going to be the part of it, and then there has to be context to it, and there has to be something into the return which is object dot name, and then we have to close it. Now that human object is available, GraphQL execution can continue with the fields requested onto it. So a GraphQL server is powered by a type system which is used to determine what to do next. Even before the human field returns anything, GraphQL knows that the next step will be to resolve fields on human type. Since the system tells it that the human field will return a human. Resolving the name in this case is very straightforward. The name resolve function is called, the object argument is the new human object returned from the previous field. In this case, we expect that human object to have a name property which we can read and return directly. In fact, many GraphQL libraries will let you omit resolvers this simple, and they will just assume that if a resolver isn't provided for a field, that property of the same name should be read and returned. Now let's come on to the next aspect, that is scalar cohesion. So while the name field is being resolved, the appears in and starships field can be resolved concurrently. The appears in field could also have a travel resolver, but let's take a closer look. Say for example, again same human, and then say appears in, and in the bracket it has the object. So this is the way we define it, and then it has to return what? So we'll say object dot appears in, So returns 4, 5, 6, say for example, and then we have to close it. Notice that our type system claims appears in will return enum values with known values. However, this function is returning numbers. So indeed, if we look up at the result, we'll see that appropriate enum values are being returned. What's going on? So this is an example of scalar coercion. The type system knows what to expect and will convert values returned by a resolver function into something that upholds the API contract. In this case, there may be an enum defined on our server which uses number like 4, 5, 6 internally, but represents them as enum values in the GraphQL type system. Now next is list resolvers. If we see, so we have already seen a bit of what happens when a field returns a list of things with the appears in field. It returned a list of enum values, and since that's what the type system expected, each item in the list was coursed to the appropriate enum value. What happens when the starship field is resolved? So now let's talk about list resolver. So we have already seen a bit what happens when a field returns a list of things with appears in field above. It returned a list of enum values, and since that's what type system expected, each item in the list was coursed to the appropriate enum value. What happens when a starship field is resolved? Now let's look at this code. The resolver for this field is not returning a promise, it's returning a list of promises. So the human object had a list of IDs of the starships they piloted, but we need to go load all of IDs to get a real starship object. So GraphQL will wait for all those promises concurrently before continuing, and when left with a list of object, it will concurrently continue yet again to load the name field on each of these items. As each field is resolved, the result value is placed into a key value mapped with the field name or alias as the key and the resolved value as the value. This continues from the bottom leaf field to the query all the way back up to the original field on the root query type. So collectively these produce a structure that mirrors the original query, which can then be sent to the typically as a JSON to the client which requested it. Let's look at one last original query to see how these resolve functions result. This is how the query can still be executed, and we can still include starships and the related different fields into it. So next we will see how introspect works in GraphQL. Coming on to the introspection, so it's often useful to ask GraphQL schema for information about what queries it supports. GraphQL allows us to do using the introspection system. So for example, our Star Wars example if we take, it contains a number of queries demonstrating the introspection system and is a test file that can be run to exercise the reference implementations introspection system. Now we design the type system, so we know that what types are available, but for example if we didn't know, we can ask GraphQL by querying the schema field always available on the root type of query. Let's do it now. So for example, if we say here, so it's about underscore schema, and then you have to query about types, and under types you may need to query about name, or you may need to query about the kind, and then hit the enter. So now, so it has got query character, human, episode, droid. So these are ones that we define in our type system. String boolean, these are built-in scalars that the type system provide. Schema type, underscore type kind, underscore field, underscore input value, underscore enum value, underscore directive. These are all preceded with double underscore, indicating that they are part of the introspection system. Now let's try to figure out a good place to start exploring what queries are available. So when we designed our type system, we specified what type all queries would start at. So let's ask introspection system about that. So for example, let's make some change into it and say in a curly bracket, again we say underscore schema, and then put one more curly bracket and say query type, and now query type shall contain name, for example, and so what we get is name query. So and that matches what we said in the type system section, that the query type is where we will start. Note that the naming here was just by convention. We would have named our query type anything else and it still would have been returned here had we specified it the starting type for queries. Naming it query though is useful convention. It is often useful to examine one specific type. Let's look at the droid type. So for example, if we say here, so for example, we are interested in knowing a depth about droid. So say, let's begin with type, and then we have name, and then what we have is droid, and under the type, what you wish to know. We wish to know what's the type, and once you hit run, so now the value is being returned as the name was droid. So what if we want to know more about droid though? So for example, is it an interface or an object? So what we'll do is we'll edit this query and ask the kind. So what kind it belongs to? So it says it belongs to the object. So kind returns underscore type kind enum, one of which values is object. If we asked about character instead, we would find that it is an interface. So for example, let's say character and try to know what it is. So it is an interface. So it's useful for an object to know what fields are available. So let's ask introspection system about droid. So what depth we like to know. So edit droid once again here, and let's say we new name now. So now let's put fields onto it, and inside fields try to know name, and let's say type, and now type again has got name and it also has got kind. So now again if you try to play it, now we know. So there are 4 fields that are defined on droid. So ID looks bit weird there. It has no name for the type. That because it is a wrapper type of kind non-null. If we queried for of type on that field's type, we would find the ID type there telling us that it is a non-null ID. Similarly, both friends and appears in have no name. Since they are the list wrapper type, we can query for of type on those types which will tell us what these are lists of. So moving ahead, let's type and check type of droid. So for example, droid, droid, and then we need name, then I need fields, and again field has got a subfield as name, and again which has got type and just got name, and it has got its kind. So now let's say of type name and kind. So once you raise this type of a query, you will be able to see of type name is string, kind is scalar. So we have got the details of it. Now let's end the feature of the introspection system, particularly useful for tooling. Let's look for documentation now. So let's put a new type of query, say for example underscore type, and put a name again because we are trying to know more about droid now. So let's say name, and here we can ask for description, and once you run it, so it says that a mechanical creature in the Star Wars universe is how it has been described. So we can access the documentation about the type system using introspection and create documentation browsers or rich IDE experiences. This is just scratch the surface of the introspection system. We can query for enum values, what interfaces a type implements, and much more. So let's talk about the errors in GraphQL. Now, query execution process never throws exceptions. Instead, all errors that occur during query execution are caught, collected, and included in response. At a very basic level, there are three types of errors in GraphQL. One is syntax error, second is a validation error, and third is the execution error. Now, let's begin with a syntax error. So syntax errors are returned in response when query has an invalid syntax and could not be parsed. So let's see how and when a syntax error is created. So for example, let's try to write a query here. So when we start with the curly bracket. Now I'll try to generate a syntax error deliberately. So I'll remove this lower curly bracket here, and I will include what I want. I want hero, and hero has got some fields. For example, there is ID. For example, there is name. For example, name has got its own. So let's go ahead and select say friends, and then leave it. And this query is incomplete since we have now not given the lower bracket down there. So let's try to execute it and see what it results into. So it says a message is being given. It says syntax error in a GraphQL request, expected name, found end of file, and it provides a location also. So line number 7, column number 2, and we'll try to close it and see what difference does it makes. So now you see a query is being executed. So this was a type of syntax error. There are many number of syntax errors. There can be many reasons a syntax error can occur. But this was the example of an incomplete bracket. Now there may be a wrong name that you may type. So this may also lead to a syntax error. So let's take one more example that is associated with the syntax error. So for example, let's do it once again. Let's start with the curly bracket in here. Let that bracket be there. It's a rest of the things are fine. But let's say in spite of writing hero, we write only HER. For example, we as a human do lots of mistake while we type. So for example, you wrote HER and you are not able to, in a code that is 100 line long or maybe 20 line long or maybe 30 line long or maybe 40 line long, you may not come across while typing, you may do that error. So but we should be able to understand what syntax error is and what are all the chances that may lead to the syntax error. Here it is really important. So for example, now hero was misspelled as HER and still we are trying to execute it. So it says syntax error in a GraphQL request, expected name, found end of file. So even if you keep a cursor here, you will be able to know that it is a syntax error at this particular location. So line number 4 and column number 3 has got the error. So these are the different examples of a syntax error. Let's say, let's do one more. Say for example, you're going to take human and in spite you forgot to put N at the end. So we are deliberately doing it, but as a human, we do that. That happens. So these are uncontrollable things. But the objective behind taking this part is so that you are able to analyze what error is, what some or certain error means over here. So again, if we try to execute it, the syntax error remains same. It says expected name but found end of file over here. So it has result into a syntax error. So we are getting message along with the location where the error is there. What GraphQL can understand the location of the error, returns the location. For example, over here it says line number 4, column number 3. So it could have been anywhere, but it responds to you with the expected place where the error has occurred, or it can see the error has happened. So you are available with the location. Now if we go and change and make those corrections and press Control space bar and include ID. I mean, what all fields you want, we can include name and again those friends, for example. So and now it says still field human argument ID of type string is required but not provided. So it requires ID as well. So this was again something we were doing wrong. So we require ID here. So ID, and since it is a string type of a data, so has to be inside a quotations. And so now let's try to run it. No, it still shows the error since the bracket is incomplete here. So you have to be very careful. So it says GraphQL expected name. Okay, so ID, so location is line number 2 and column number 18 where it has found the bracket is missing. So after providing the ID, we were supposed to close the bracket, which I forgot. So and friends, it shows the wavy lines under it. So it means it has got some of its own fields which needs to be included while you are raising the query. And it may be it is having the ID. So now it seems no, still there is the error. So syntax error, expected name, found end of file. Let's analyze once again why it's, so maybe now it is complete and it returns the query. So data, human, ID so and so, the name is Han Solo, friends have got those IDs. So it is really very important for you. Obviously, this is not something that can be avoided, but you must read the error, understand what sort of mistake has happened, and according to that, you have to make those corrections and execute the query and code. So syntax error, it's a very common type of error which usually we come across because we may do a misspelling, we may misspell, or we may forgot to end the brackets while you are typing a big code, or some of certain things that we do while we are in a hurry to write a code, or we may be doing some tasks. So it is really important to understand the error, know the location, go on to that particular location, make those corrections and then execute it again. So this is about syntax error, and now we'll begin with the second type of error, that is the validation error, in a next part. Coming on to the next part, that is validation errors. Now what are validation error? First I have to understand. So validation errors are returned in response when a query has semantic errors. So example, output field for invalid query. So for example, let's try to write a query. Now for example, we try to query hero, and we, just a moment, we change it, we just take a human for example in here, and put the ID, say 1002, let's keep it same. Now human have certain field, so if you press Control Enter, we are able to see what all fields exist. But for example, if we try to put some field which does not exist in human, it will give us the validation error. So it says cannot query field episode on human, and location is line number 3 and column is 5, where you have given episode inside human. So this creates the validation error. Now to avoid validation error, it is really important for us to know what is the schema of the data that we are possessing, and apart from that we need to understand what are the columns that can be queried in a one particular field. Now for example, let's keep it as human, and now you put ID, now you put name, and now you put friends. Now friends have got its own subfields, so it is again say appears in, if you would like to keep. Now you execute this query, we have got the information. So it says data, human, ID so and so, so it was 102, and name was Han Solo, so friends, and inside that we had raised a query for, or we had asked for the subquery which was appears in, so it has returned with New Hope, Empire and JEDI. So this is the way. Let's take another example. So let's take hero as an example, and in the bracket we have to specify the parameter. So that is, press Control Enter, and say for example we take Empire, and now there are subfields that are need to be selected. So we keep ID, we keep name, we keep friends. Now friends has got its own some fields, so let's choose only ID for this example, and now execute the query. So everything is working fine for the time being, since we have not queried anything, or we have not asked for anything that is outside the scope of hero, but let us say we deliberately introduce a wrong field. Say for example, we will write here episode, just for the sake to understand, and now execute it. So it says the same error that we got earlier too. So it says errors. So what is the error? So message has come as cannot query field episode on character. So and the allocations are line number 5 and column number 5. So this is again a validation error. So these have been returned into the response, since because the query that we had asked, or subfield that we had asked on a hero, is not acceptable because episode does not exist inside hero as a column in the data. So it has not been returned. In spite of that, the error has been thrown back. So now if you remove the episode here, so again this is a valid query. So this is about the validation error. So as explained earlier too, so to avoid the validation error, it is always important to know the subfields in a particular field, and to know the schema. There are schema errors as well, but it's better to know the schema before you start querying, because in a long code of 20, 50, 70, 80 lines, it is difficult to then trace back. So it is better to know the schema and then raise a query to avoid these sort of errors. And always it is a good practice to know what is actually the field that are existing. So pressing a control enter, and then maybe selecting the appropriate field. So next, come on to the execution error in the next part. Execution errors included in response when some field resolver throws or returns unexpected value. Example, output for a query with exception throw in field resolver. So let us see what can be the execution error. So for example, if we take for example hero here and try to put episode, first we'll execute it in a usual way, and then we'll see how actually errors are encountered, such as execution errors are encountered. And when you run this query, we are getting the response as we have sent a query as. So for example, now you say JD, if it is there in the data, we'll be getting it. Now for example, you give any other name. For example, you say human here, which is not something that is existing. It has returned with the value. So argument episode is invalid, value human. So this is the different error altogether. So it says that human was not something that was present inside the episode, which cannot be raised as a query. So this is when you give the wrong value, we come across the execution error. This is not actually the execution error, but this is also the error when you provide any wrong value while you are raising a query. So let's look at another example. So for example, you take human here, and we are supposed to provide the ID. Now we are taking some valid ID for the time being. So it is always necessary to understand what happens when you put or ask for data, when you put a query. So for example, there are 3 fields that we are asking for, and we have provided with the ID 1002, and now once it executes, it has returned everything that it had. So maybe home planet was not the data in the particular ID 1002. So this is null is being returned. So this is considered as a execution error. But this is because home planet field had no data for 1002. But what if I provide a wrong ID itself? So let's go and check. If we say remove 2, and now if we put the query, it says it is null. Now if you look at it here, it has not given any error. So there is no such error message into it, but still the data is null. This is considered as the execution error. So when syntax and validation error is detected, process is interrupted and query is not executed. In such scenarios, response only contains error but not data. GraphQL is bit forgiving in execution error which occur in resolvers of a nullable field. If such field throws or returns unexpected value, the value of the field in response will simply be replaced with null, as we saw in the earlier example, and error entry will be added to response. If exception is thrown in a non-nullable field, error bubbles up to first nullable field. This nullable field is replaced with null and error entry is added in response. If all fields up to root are non-null, data entry will be removed from the response and only error key will be represented. So as we saw in earlier example 2, it's like home planet was not something that was present in 1002. The field was replaced with null value, but when there was no data for that particular ID, the entire root till human was replaced with null. So if you want to try, we can try any other example based on that. So another example is belongs to, say for example, droid, and you provide the ID, say for example in double quotations, say for example 1, and raise the subfields. It's ID, name, and friends, and now you hit the play button. So it says null because the ID is wrong, so it gives out the execution error here, or you may say 4 maybe, but these are not the applicable IDs for droid. So we have got null as the output response. Now this is about the execution error here. So in the next session we will see what are the debugging tools which can be used to understand the error. So let's talk about the errors that happen or that occur whenever we try to raise a query. So here is what we saw. So for hero, we are providing the episode, say for example New Hope, and then we are choosing ID. You might be choosing name for example, and you try to run it. This works absolutely fine. But if I choose any field that doesn't suit here, say for example episode. Okay, we took this example earlier too. So it says the message cannot query field episode on character. So along with giving out the error, it also provides you with the line and column. So that means locations are always provided into the error to understand where error has happened and where we have to go and rectify it. So each error entry contains pointer to line and column in original query string which has caused the error. So here if we observe, so line number 5 has got episode and it has got column number 5 where E starts. So that is where error lies, is being reflected. So locations are clearly reflected whenever the error happens. Now GraphQL clients like Relay or Graph GraphQL leverages this information to highlight actual piece of a query that is containing the error. In certain cases, like if I say deep fragment fields, locations will include several entries to track down the path to field with error in a query. So execution error also contains path at certain number of times from a very root field to actual field value producing an error. So including indexes for array types and field names for object types. So in complex situations, it may happen that you will be provided with the path right from the root to the point where error has occurred. So this is how it is easy to understand, recognize and rectify the error in GraphQL.